Assalamualaikum. My name is Farah Aziera binti Jamaludin. Okay, today I will present my review paper about use of spent garnet waste in concrete. Now I will introduce a little bit about my paper. So, Tunggal 2020 reported the concrete industry is expanding 9 billion tons of sand and gravel per year and 1 billion tons of water mixing, 1.5 billion tons of cement. So, as this concrete demand increases, those industries primarily responsible for declining natural resources such as sand aggregate and will lead to environmental imbalance due to its massive use of aggregate. Measures also have in that garnet industry that use for water jet cutting, abrasive blast medium and powder, coarse grain, filtering grain and coarse grit. So, the waste of garnet, which is called spent garnet, will dispose into the landfill and will create the environmental issue. First problem why I made this paper because of the issue of sand mining and impact to the nature. As I mentioned before this, growing construction needs more sand. By mining out in excessive quantity will affect the environment and living organisms, such as damage to river embankment, climate change, biodiversity, and water turbidity. Next problem is spent garnet waste. According to statistical record, MMHE import 1,000 tons of garnet from Australia for their service operation, reported by Muthusamy 2018 and Hussein 2019. This garnet can be reused for their proprietary asset approximately 3 until 5 times before they withdraw from the shipyard that marked as a spent garnet that we throw into the landfill that will create some environmental issue. Okay, this is my literature review that I have reviewed for the spent garnet waste. All of this is reported by Muthusamy 2018, which is spent garnet appears like a darker version of sand. We can see from my previous figure. Okay, we can see this spent garnet a little bit darker than a river sand. Next, I will present some results that I have reviewed for the spent garnet in concrete and the mortar. First researcher is Hussein et al. 2019 that tells flow table tells for the fresh properties of the mortar. The result is increased. Same goes to the Muthusamy et al. 2018, but for Muthusamy et al. 2018 make a concrete. Based on the result, we can conclude 25% of total sand replacement cause increment in workability of mortar and a concrete. Next, I will discuss about the mechanical properties of the spent garnet in concrete or the mortar. We can see on the table we have 4 researchers that report the result of the mechanical properties of spent garnet in concrete and mortar. For the Kion 2018, replace different percent from the other research Kion make high strength concrete. The result from Kion research, it increased at 40% for the compressive strength and splitting tensile strength. Okay, for the Muthusamy et al. And Hussein, same replacement for the spent garnet. Muthusamy it made a concrete specimen, but for the another 2 researchers it makes mortar specimen. Muthusamy report decrease for all replacement, but for the Kuncharikun and Hussein reported increase for all replacement, but for Hussein reported increase at 25% of the replacement. The next is I will discuss about the durability properties of spent garnet in concrete or mortar. Based on 2 figures, we can conclude use of spent garnet 25% produce a mortar with lower water absorption compared to other replacement. But we can see from this figure reported by Muthusamy et al. 2018, for 25% replacement is higher compared to the control specimen, but the water absorption of concrete containing from 25% up to 100% spent garnet and sand replacement does not exceed 6%. Okay, categorized as a good quality concrete because according to Nabilah, 2019, concrete with water absorption not more than 10% is considered as a good quality. So, okay, this result for the acid attack resistance. You can see from these two figures, this mortar residual compressive strength after emission in sulfuric acid reported by Hussein et al. 2019, and this weight loss of self-compacting geopolymer concrete due to acid attack reported by Muthusamy et al. 2018. Okay, Hussein et al. 2020 reported 25% of spent garnet as having higher resistance than plain concrete in sulfuric acid solution. The integration of the exact quantity of spent garnet will able to better pack internal structure that will lead to the higher resistance of the concrete and the mortar. The lower resistance of the concrete and mortar is due to the existence of pore structure that permit the transportation of destructive element into the attack material and will leach out the product form after attack. The higher fraction of spent garnet will suffer greater weight loss due to the higher tendency to absorb acid in contrast to the control specimen that reported by Muthusamy et al. 2018. Conclusion of this research is the properties of this waste material with higher hardness and finer size make it feasible to be utilized as a partial fine aggregate in concrete or a brick production. So, more discovery of spent garnet use in construction building material research need to be carried out to expand its use in the construction industry. This is some reference that I have referred for this review paper. So I think that's all from me. Thank you.